Our lesson today is about types of bonds. In order to understand the types of bonds, we have to know the meaning of electronegativity. The modern definition of electronegativity is due to Linus Pauling, and it is the power of an atom in a molecule to attract electrons to itself. Pauling was able to develop a numerical value or numerical scale of electronegativities, and 10 common elements with these values are fluorine with electronegativity value of 4.0. As you notice, fluorine has the highest electronegativity value, followed by oxygen, followed by chlorine. And then we have also nitrogen 3.0, carbon 2.5. Now, what are these values? When we get the difference in electronegativity values of the two atoms in a molecule, then we will be able to determine the type of bond. Nonpolar covalent, there is equal sharing between the two atoms of the electrons in the bond. So example are molecules of chlorine, hydrogen, and fluorine because their electronegativity difference is zero. And it makes sense because they are similar atoms, right? Okay, it indicates nonpolar covalent. The next type of bond is polar covalent. There is unequal sharing of electrons between the two atoms in the bond. An example is H2O molecule, and the difference in electronegativity ranges from 0.5 to 1.9, polar covalent. Another type is ionic bond. There is a complete transfer of electrons between the two atoms. So there's no sharing here. It's transfer of electrons in the bond. And substances such as sodium chloride, NaCl, and magnesium chloride, MgCl2, are examples of ionic, and we will show that in the next slide, the difference between electronegativity of these two atoms. The rule is that when the electronegativity difference is greater than 2.0, the bond is considered ionic. The rules. So let us review the rules. If the difference again is less than 0.5, then the bond is nonpolar covalent. Again, how do we characterize nonpolar covalent? There is what? Equal sharing of electrons. And if the electronegativity difference is between 0.5 to 1.9, the bond is polar covalent. And it is characterized by the unequal sharing of electrons. If the electronegativity difference is greater than 2, then the bond is ionic bond. Ionic bond. Okay, in this rule, if the difference in electronegativity is between 1.6 and 2.0, then if the metal is involved, then the bond is considered ionic. But if only nonmetals are involved, then the bond is considered polar covalent. An example is sodium bromide. The electronegativity of sodium is 0.9. For bromine is 2.8. The difference between the two is 1.9, right? So therefore, we say it is a ionic. Why ionic? Because the value is between 1.6 and 2.0, and Na is a metal. What about hydrogen fluoride? Hydrogen is a nonmetal, fluorine is a nonmetal, and the difference between the electronegativity is 1.9. Therefore, we say it is a polar covalent. So we use rule number 4 to decide that NABR, because the electronegativity is less than 2.0, we say it is ionic bonds because Na is a metal. And HF is a polar covalent bond. So here is an example. We have the types of bonds when between hydrogen and hydrogen. 2.1 is the electronegativity value of hydrogen. And of course, between two similar atoms of hydrogen, it makes sense that if you get the difference between their values, the difference is equal to 0, right? This symbol means difference in electronegativity. This one, between hydrogen and bromine, hydrogen bromide or hydrobromic acid, is a polar covalent bond because the difference between the electronegativity 2.8 for bromine and 2.1 for hydrogen, when you subtract, you get 0.7, and it falls under the range of, remember, polar covalent bond. Remember, the range of polar covalent bond is between 0.5 to 2.0, right? Now, ionic, sodium is 0.9, chlorine is 3.0, the electronegativity difference is 2.1. 3.0 minus zero point 0.9 is 2.1. So that's it. We can determine the types of bonds based on the electronegativity difference, and all we need to do is compare it with the range, and we can classify the bond that exists between the two atoms.